Okay, so this is another quick run through of the last lab on transients. So let's have a look at that. So again, I've got LT spice on the left, and I have the circuit diagram that we need to put together on the right. But this time, instead of the sine wave, we need to make sure we have a square wave. So let's draw the circuit, and I'm going to draw the outline like I usually do, and then I'm going to have a voltage source, and we'll go advanced, and we'll go, I think pulse is the right one. So the V initial, let's make the V initial 0, V on is 10 volts, and let's just see what that does. Time delay of 0, rise time of 0, T on, T period, and we need 50 Hertz, so the period's going to be 0.02, 20 milliseconds. Let's see if that works. And then we need to have a resistor, and Control R to get the resistor, and 1200 ohms. And then we need to have a capacitor, and this one's going to be a 10 microfarad capacitor. 10U should be enough. And there we go. I need to have a few other things, as we saw earlier. I need to have a spice directive, and .tran1 is probably enough for this. Put that up there. And the net name, we need to make sure we have the ground and connect it up, and that should be enough to run it. There we go, and run that, and let's select a that voltage there, and there we've got something looking sort of like what we want, but it's not quite right. So let's have a look at what we've got. We've got a 10 microfarad, and we wanted a 50 Hertz square wave. So let's just have a look and make sure our square wave is right. Our square wave is sort of right, except that our it looks like it's probably got the right yeah, it's got the right period of about 20 milliseconds, but it's not got the right on time and off time. So let's have a look at what we need to do to get that. So we want the on time to be about half, so half the period. So let's go with 0.1, and let's rerun it and see if that works a little better. That's working a little better, but now we've got right, it's not quite the rising of each of these is stopped, because, or it doesn't finish, it doesn't reach its asymptotic value before the voltage changes. So let's just have a quick look as to why that might be, and I'm going to put another page in here, and we'll do a lab 9. Right, so our resistor was 1200 ohms, our capacitor is 10 microfarads. So those two combined mean that our tau, our time constant, which is for a resistor capacitor circuit, is RC, is going to be 1200 by 10 times 10 to the minus 6. And what does that come out to be? So what's that? That's 1.2. It's just 1200 times 10 times 10 to the minus 6. 0.012 seconds. Right? So the time constant is 0.012 seconds. And remember, and what we'll hear in the lab is we want, in the lecture, is we want our steady state, well, we're not going to reach a steady state until we're at least 5 tau through. And because this number is quite a bit, is just a little bit over half the period, it's not going to reach steady state. So let's just go back to our LT spice, and instead of having a period of 0.02, so what's 5 times 0.012? That's 6. So let's make a period. Let's just make a period of 0.1. And let's make a period of 0.2 and a T on of 0.1. Right? And let's just rerun that. And now it's looking much more like what you'd expect, right? You can see if we zoom into just one of these, you can see now that the e to the minus t on tau shape is there, and it reaches the asymptotic value pretty closely, certainly within 1%, like what we want. Okay, so I think that means I need to change that 50 hertz to a, well, what did I change it to? I changed it to a 5 hertz. Anyway, that should get you started on the lab, and I'll talk a little bit more about it during the session.